So this experiment we are going to conduct for determining the thermal conductivity of given metal rod. So this experiment is being called as heat transfer through metal rod. So heat is a form of energy that can be transformed from one system to another due to temperature difference. Heat can be transformed in conduction, convection or radiation. In solids, heat is transferred in the form of conduction. This is due to variation of the atoms and movement of free electrons. The rate of heat transfer depends upon geometry of the material and to the gradient of the temperature in that direction. So here we have been conducting this one based upon the principle of Fourier's conduction law. So what is that Fourier's conduction law? The rate of heat flow by conduction in a given direction is proportional to the area normal to the direction of heat flow and to the gradient of temperature in that direction. So here based upon this Fourier's law equation, what we have been having, Q is equal to minus K capital A dt by dx. Okay. So this is where Q is then a rate of heat flow through an area of in the positive x direction, and here the heat flux is represented with a Qx. So heat flux is in the positive direction. The proportionality constant which we have been using here, that is a small k, it is been called as a thermal conductivity of the material and is a positive quantity. Thermal conductivity is a measure of the ability of material to conduct the heat. A good conductor is having a high thermal conductivity and poor conductor or insulator is having a low thermal conductivity. This is highest value is for highly conducting pure metals and lowest value is for gases and vapors. Thermal conductivity is also varies with a temperature and even it is based upon the material what we have been using. So now let us see what here in the experimental setup, what are the things we have been having. So here in this experimental setup consists of a copper rod which is being there inside of this insulation, and this copper rod having an electrical heater at one end and another end it is being connected to the water jacket. So here you can see this is in a path. So this is in a water jacket. So where it is been connected to a water flow, and this is been having a flow meter. So through this you are going to make an adjustment what is in a quantity of water can be flowed into this copper rod. The middle portion is surrounded with a cylindrical shell. So this is in a middle portion which is being surrounded with a cylindrical shell filled with an insulated powder, and 5 thermocouples are placed on the bar for temperature requirements. For radial measurement of temperature, 4 thermocouples are placed at a radius of 42.5 mm and 55 mm in the insulating shell. So totally we have been having 6 thermocouples which have been placed at a 60 mm. So this you can see the inside it is being placed. So outer surface it is not being visible. So these are the connections what we have been having. And here in this setup you are going to have this main switch which you are going to on for the power supply, and next thing when you are going to on this one, you are going to heat is being the electricity is being supplied to the copper rod. So it acts like in a copper rod, here acts like a heater. Then you are going to have this temperature indicator. So where for different thermocouples we can find out what is the temperature. Okay. So here we have been having an ammeter. So what is the current which is being passed, and we have been having a voltmeter to measure the voltage, and we have been having an auto transformer. So what is the quantity of electricity to be passed or how the temperature can be controlled. So this is the knob where you can control the flow of temperature. Okay. So let us see the procedure how to conduct this experiment. So first we are going to on the system. So this is the knob where we are going to on the system. Then we are going to adjust the flow meter. Okay, this is a rotometer where the flow of water is being measured. So this is what you are going to adjust. So here you can see by this knob you can adjust to what is the flow of water is being required. Then afterwards you are going to on the heater. This is a heater knob. So once it is been on, you need to adjust what is the amount of power need to be supplied. So that you are going to adjust with auto transformer. Okay, so when you are going to adjust with auto transformer, we need to maintain the flow of current in ammeter and in the voltmeter. Then afterwards, here we have been having a different set sensors, thermocouple sensors. From that one, we are going to find out the temperature of T1, T2, T3. Like this, we are going to find out the different thermocouple sensors. We are going to find out the temperatures. Okay, so you have to maintain this for at least 10 to 15 minutes. Then afterwards, you need to take the readings. So here you can see the configuration. So here the material inside the used is copper, and the length of that copper rod is 0.450 meters, and the diameter of the rod is 0.030 meters. The test length is 0.320 meters. Okay, so here we have been, so at temperature T1 we have been finding out the heater temperature. From T2 to T7 we have been having a surface temperature. T8 is in a water inlet temperature, T8 is in a water outlet temperature. By changing this knob at different points, you can find out the temperature. So let us come to the calculation part. So here cross section area of the metal rod we need to find out. So that is equation capital A is equal to pi by 4 d square. So you know the diameter of the metal rod, so which the copper rod we have been taken, that is 30 mm. So by substituting this value here in this d square, we can get the area of the metal rod. Then afterwards, you need to find out what is the heat input rate. So that is voltage and the ammeter. So you can find out what is the heat is being passed to the inlet. So here next is the heat carried away by the water. So the water is made to flow over the copper rod. So the heat absorbed by the water, that is an equation given by, so mass flow rate of water and specific heat of water and the temperature difference. Here the temperature difference is the temperature at the water outlet and temperature at the water inlet. So by finding out, we can find out, so what is an heat carried away by the water. You know the mass flow rate of the water, which you can calculate through that instrument photometer. Then you know the specific heat of the water. Okay, after finding out, you can come to the conclusion that so heat carried away by water is equal to heat absorbed by water. So this equation is being equal to Q actual. So that is heat carried out by the water and heat conducted through the metal rod. So when you take heat conducted to the metal rod, you know the value of QW, and this K is the thermal conductivity. So this is the thing we need to find out. So you know the value of the area A, so which is been calculated here, and here we need to find out dt by dx. So this is a temperature gradient. So for this one we need to draw the graph. So with help of thermocouple we have been found out the temperature at different points. So we are going to draw the graph. X-axis has a distance and y-axis has a temperature. By taking the slope of that graph, you will get the value of dt by dx. You know the value of dt by dx, you know the value of area, so you know the value of QW. So then you can find out the value of thermal conductivity of the given metal rod. So after conducting the experiment, so we have to wait for 10 to 15 minutes so that we can get a constant readings. So here through the rotometer you have been adjusted what is a flow rate of water. That one reading you need to take here. Then that need to be converted into kg per second. And whatever the reading you have been getting from the voltmeter, take that reading here. And from the ammeter, what is the reading you have been getting, you take here. And through different, with help of thermocouple, we have been finding the temperature of heater temperature. That is been shown as in a channel 01 in the experiment. Note down here at T1, and next on the surface temperature over the copper rod we have been having T2, T3, T4, T5, T6 and T7. So this have been placed at a distance of 0.60 mm. So here the water temperature you are going to find out. So T8 is the temperature of water at the inlet and T9 is the temperature of the water at outlet. Then you are going to find out what is in a Q theoretical and what is in a Q actual. Then with help of these values you could able to find out the thermal conductivity. So now let us move on how we are going to conduct then a calculation part for this tabular column readings what we have been taken.